Hello, this is Algorithm, and today we will be going over problem A of Codeforces round number 636, which is called Candies. So the problem statement is, recently Vova found N candy wrappers. He remembers that he bought X candies during the first day, 2X candies during the second day, 4X candies during the third day, 2K minus 1X candies during the kth day, but there is an issue. Vova remembers neither X nor K, but he is sure that X and K are positive integers and K is greater than 1. So over here, what the problem statement basically is that you have this equation. So you're given N, and you want to find an X that works. So for example, the first part of the input is T, the number of test cases. Then, for each T, you have an integer N, which you want to put into this equation. And from here, you want to find X. So to run through it, for the first input, we have N equal to 3. So we're going to start computing this equation by letting X starting with 1. So if we let X equal to 1, then we get 1, which is not equal to 3. So we go to the next one. 1 plus 2 times 1 is 1 plus 2, or 3. 3 is equal to N, therefore if we let X equal to 1, we can get N equal to 3. And keep in mind that there can be multiple solutions.
So in order to solve this problem, one key observation we can make is that x plus 2x plus 4x all the way up to 2 to the power k minus 1x is x times 1 plus 2 plus 4 dot dot dot. And what this observation allows us to do is that we can split n as a product of two factors. X times 1 plus 2 plus 4, so on, to whatever number you need. So from here, what we can actually do to easily and efficiently find x is that we can divide both sides by this 1 plus 2 all the way to the number which you want. So what we can do is that we can start with 1, and then we can divide n over 1, and then we can get our value of x. If n is divisible by 1, this means that we can get a value for x. If it is not, then we have to add on to the next one, which is a 2. So then we go to n over 1 plus 2. And then we check, is this divisible? And if we get a quotient with no remainder, then we can set this equal to x. And then we can move on to n over 1 plus 2 plus 4. Then we can set this to x over and over and over again, just by using this one equation. But keep in mind that k has to be greater than 1. So this n over 1 equal to x is not a solution. But these, and moving forward, are solutions.
Now let's go on to the actual implementation of this solution. So here we have our integer t, and we CNT. T is the number of test cases. So now we want to input all of this n. So for each test case, we're going to create our integer n and input n. And then we're going to put this n into a function called run. And what this run here is that we are basically going to calculate the 1 plus 2 plus 4, and at each step after adding a new number, such as from 1, and then we're going to add 2 to it, and we're going to test 1 plus 2, then add 4, and test 1 plus 2 plus 4, and you're going to keep on testing this. So what our total is the total is the sum of 1 plus 2 plus 4 all the way up to the number which we get at the end. So this is what total is, and it starts at 1, and then we add counter to it. Counter is the number which we're going to add to the total each time, such as we're going to start with 1, then we're going to add 2 to become 3, so total will be 3, counter will be 2. Then counter, after we have that, we want to add 4, which is the next one. So then counter becomes 4, total becomes 3 plus 4, which is 7, and so on. So over here, counter is being multiplied by 2 because it goes from 1 to 2 to 4 all the way to the 2 to the power of k minus 1. So that is what counter is. Total is going to be the sum of everything. And then over here, we are going to check if the number is divisible by the total sum which we have right now. If it is divisible by it, then we're going to return the number divided by total, as stated in our solution. And then keep in mind, we start total equal to 1, and we immediately add counter to it, so it starts off at 3 at the actual beginning. This is because we do not want total equaling 1, because we want k to be greater than 1. If total equals 1, then what we will have is that it'll just be x is equal to n, and we do not want this. So therefore, we immediately started over here where total is equal to 3, and then we start computing sums, running over and over again until we can print out our answer, and then we can return 0 at the end. So by running this code, we can see that it is accepted and we do get the answer correct.